Hello students, today we will start with our first lesson in grade 7, which is powers. With me, teacher Mariam Santino. Please put a copybook in front of you and take some notes. At the end of this lesson, we will be able to use the notation a to the power n put in the form of a power the product and quotient of two powers of positive numbers, put in the form of a power the power of a power of a positive number. Already last year you took this lesson. So let me ask you some questions. What do you know about powers? Do you remember why do we use powers? What do powers indicate? Think about these questions. Who can relate this lesson with our daily life? Of course, it can be related in our daily life. Please now watch this video. Then we will continue after watching.
A frog population doubles every 3 weeks. If at present there are 10 tree frogs, can you find the number of frogs at the end of 6 months? At the end of this lesson, you should be able to define exponents using positive integers, write numbers in exponential form, evaluate numbers written in exponential form. At times, when we come across very large numbers, like when we talk about the solar system, the mass of Earth,
A very big
distance of
number.
Earth from the Sun, and Saturn from the Sun, are all very large numbers. These numbers are difficult to read, understand, and compare. So, we need a better way to represent them. In our day-to-day life, we often use abbreviations as short forms for a big word or name of an entity, like UNESCO is the acronym for United Nations Educational, Scientific and Cultural Organization. Similarly, we use ISRO for Indian Space Research Organization and SBI for State Bank of India. Have you ever thought why we use these abbreviations? We use abbreviations because they give shorter, easier to remember words for large names. Is there a way we can do something similar with numbers? Now, we take a large number like 10,000. It can be written as 10 multiplied 4 times or simply as 10 to the power of 4. This representation of the number using a shorter term is done using exponents. Here, 10 is called the base, which is the number that is being multiplied, and 4 is the exponent, which represents how many times the value is being multiplied. This is read as 10 to the power of 4 or 4th power of 10. So, exponents are shorthand for repeated multiplication of the same numbers by itself and can be used to represent very large numbers in an easy to understand way. Till now we saw numbers with 10 as the base. Can we express numbers like 27 in exponential form? "27 can be written as 3 into 3 into 3 or 3 to the power of 3. So, exponential representation of numbers need not have only 10 as the base. We could have any positive or negative integers as the base.
So, we conclude that the main reason we use exponents is because it is a shorter way to write out a big numbers. 2 is repeated 6 times as you see. So instead of writing 2 6 times, we can write it 2 to the power 6. What is a power of a number? 2 exponent 4. 2 is the base and 4 is the exponent. And it is equal to 2 times 2 times 2 times 2, which is equal to 16. What does the base indicate? It indicates what a number I have to multiply by itself. And the exponent, how many times I will multiply the base. How to read 3 exponent 2? We read it 3 to power 2, 3 exponent 2, and there is a special case which is 3 squared. Always when we see exponent to the power 2, we say directly squared. Now, how we read also another example, 5 to the power 3, 5 exponent 3, and here we also have a special case which is 5 cubed. When we see exponent 3, it is called cubed. So, can you find the answer of 3 to the power 1 and 3 to the power 0? Let's start by finding the answers of 3 to the power 5, 3 to the power 4, 3 to the power 3, and 3 to the power 2. 3 to the power 5 is equal to 3 times 3 times 3 times 3 times 3, which is equal to 243. 3 to the power 4 is equal to 81. 3 to the power 3 is equal to 27. And 3 to the power 2 is equal to 3 times 3, which is equal to 9. What do you notice? We notice that the answers are decreasing. And if we divide 3 to the power 5 with 3 to the power 4, the answer will be equal to 3. And if we are dividing 3 to the power 2 with 3 to the power 1, what will be the answer? Think about it. The answer will be equal to 3. What about dividing 3 to the power 2 with 3 to the power 1? The answer will be also 3. So 3 to the power 1 is equal to 3. And this is the correct answer. While 3 to the power 0 is equal to 1 because we are dividing by 3. Now you have to notice that, and I want from you to write it on your copybook, any number to the power 1 is the number itself. So 3 to the power 1 give me 3. 5 to the power 1 will give me 5. 10 to the power 1 will give me 10. And the second note, any number to the power 0 is equal to 1. So 3 to the power 0 will be equal to 1. 5 to the power 0 will be also equal to 1. And 10 to the power 0 is equal to 1. Now let's calculate. Calculate and evaluate have the same meaning here. And I want from you also to write these on your copybook and try to memorize them because they will help you later. 2 to the power 3 is equal to 8 since we are multiplying 2 3 times. 10 to the power 4, instead of writing 10 times 10 times 10 times 10 4 times, I can write 1 and in front of it 4 zeros. 3 to the power 3 is equal to 27. 8 to the power 2 is equal to what? It's equal to 8 times 8, which means it's equal to 64. What about 5 to the power 3? 5 to the power 3 is equal to 5 times 5 times 5, which is equal to 125. And 2 to the power 5 is equal to what? 2 times 2 times 2 times 2 times 2, 5 times. So the answer is equal to 32. Now, 7 to the power 0. It's from the rule that we took before. Any number to the power 0 is equal to 1. So 12 to the power 0 is equal to 1. And Any number to power 1 is a number itself. So 10 power 1 is equal to 10, and 5 to the power 1 is equal to 5.